Okay, the Android lecture. Oops. So I'm pretty much going to do the same thing. I'm going to lecture for part of the course, and then we'll start working with project number 1 on the Android assignments. So project number 1 is a piece of cake, actually. It's really easy. We can probably finish the whole thing today. So you'll have 1 down for this class. So if you keep showing up, now next time I'm going to have more power for you. I got tables this time, which is good. So next time I might even have power, so you can even, power your notebooks as well. One milestone at a time. All right, so today what I'm going to start with then is basic Java programming. Not really. We'll be looking at classes, what we've looked at so far, which is nice because you guys are some of you are taking the object-oriented programming in Java course. The concept of Java as is implemented for the Android, advanced topics touching on I/O, threads, and sockets, which are a little bit different. So it's a lot of concept stuff that's in this first lecture. But there's a little bit of overlap, so I'm going to kind of skip through it, starting with lecture number 2 with the better slides of the overlap. That's what I'm going to do. We all know this. Credit goes to Google, I hope. These are actual Google slides, but they're kind of dated at this point, so that's why I'm not really going to cover all of them. In terms of the objective, and this isn't really the course objective, but this is, I'm going backwards because I never covered this lecture. Can we, I'm sorry, I just don't want to talk over you. Thank you. That's okay. We're good. Nobody ever says MAD anymore, but mobile application development, that was like a buzzword that was supposed to be out popular. Well, why? I mean, it sounds pretty bad. But what we're going to look at, and what I want to talk about is the Android platform and the Android architecture, and then the building blocks and development tools. And then we're going to do the Hello Android little getting started app, essentially. It's a few reasons to go mad. Smartphones are everywhere. Obviously, millions of mobile users. Open standards. It's all Java. So in terms of the introduction, what we're looking at is the open source mobile platform written in Java, which is probably all we know about it at this point. Hopefully you have it installed, I hope. Complete stacks. We have an operating system, middleware, and applications that are built on there. And I'm going to show you the framework in a few minutes. And you're going to go, whoa. It's really a Linux kernel. And it's really built with modules with a framework support that supports all the different functionalities. It is from the Open Handset Alliance project, powered by Linux, so it is a true Linux kernel. Fast development through Java, open source under Apache 2 license. Here's the slide that I was talking about. This is the entire framework of the Android system. From a programmer's perspective, you see this, but you don't see this. From an Android developer, in terms of building kernels, you really see this a lot because you're going to add support and then change support for certain things. And this is how our 2.0 versus our 3.0 versus our 4.0 Android kernel changes. So if you ever wonder what's the differences between all these different builds, from ice cream to gingerbread to all the different code names, it's just different kernel builds with modified functionality and in some cases enhanced functionality to work with the hardware that's changing and becoming more advanced. So as hardware grows, changes, adapts, processor speeds get faster stuff, well, so does the kernel. So the kernel itself is broken down into these components. What we're doing is writing programs for the Android runtime, which is a application of core libraries, putting the core libraries together on a DVM, on a Dalvik virtual machine, which is the equivalent to the JVM. So in the Java course, we're using the JVM. In Android, we're using the DVM. So it's pretty much the same concept, running the same way, except for we don't actually have to load the Dalvik kernel. The machine it's actually part of the runtime environment that's loaded for us automatically on the Android phone. The same runtime machine runs everything. Even all the services, all of the features of the phone are all run from the same DVM. So what are we looking at from a kernel perspective? We have the module implementation, and if this were a computer, the architecture would look identical. In fact, you could take the Android kernel and load it on regular old hardware, as long as you swap out the control for the drivers. So it's a layered architecture, and it's helpful to know the pieces of this, although you don't have to build a kernel for this course. But the Linux kernel component is going to be the modules for the display adapters, for the phone, the memory, the flash memory, audio drivers, everything that would fall under the hardware, power management, Wi-Fi drivers. In your different kernel builds, this is the significant change. The library framework is pretty much the same. It's, you know, obviously bug fixes and enhancements throughout the different versions. But this is the kind of the difference. And if we keep the libraries the same and the application framework the same, we keep everything all up here pretty consistent, then we can have programs that run on multiple different kernels, and it all works the same. So you can compile one program that works on 2.1 all the way through 4 point something, because it's all compatible, which is great. It's just the lower level kernel implementations are different for supporting different hardware. In this particular class, we're going to be looking at the SQLite libraries. We'll also be looking at the WebKit as soon as next week, actually. libc, which is the library, SSL for security, all the different OpenGL, not really going to look at very much, but if you're writing games and doing a lot of game program, you can write directly OpenGL. It's the same way that you would do through a regular old Linux kernel. You can write OpenGL applications using OpenGL, believe it or not, the same library that you're using on the Android phone, which is great because it really does add a lot of good 3D graphic capabilities for games and stuff, which is kind of important.
Is WebGL the same thing?
Yep, WebGL is a variation of OpenGL. It actually works the same way. Imagine this is a small computer running a Linux kernel. It's the same thing. The application framework is kind of like what we're looking at today in terms of the view system, the activity manager, window manager, resource manager, location manager. All of the different managers all are dissected out for different special purposes, and the special purposes is to organize and configure the different components that you're going to use. One program can use all of this stuff. It can use content providers, location manager. It depends on what the program is actually doing as to how this is going to be operating. From an application perspective, you can program and work with the existing applications with the web browser. In fact, that's what the WebKit works directly with the browser capabilities. You can actually customize and inherit from that browser, create your own browser if you want to. It's really easy. The phone features the dialing, stuff like that. Contacts as a provider, as a content provider. The home, the browser. Anyway, there's the ... is everything that you could possibly imagine that's on the phone. Yeah?
I think I can hear it in the music, but I don't know where it's from.
Music?
It's from the hallway.
Oh, does someone want to shut that door then? Maybe? And that might help them. Well, thank you for pointing that out. I don't hear the music from over here. You guys hear the music?
It's the
Why do they play music in the hallway? I mean,
It is
let me
the-
listen. Let me listen.
Yeah, sometimes it's
No, well, you know, I have allergies. My nose and ears are kind of stuffed up, so I can't hear a thing.
It's repeating like every 15 seconds.
Go outside, breathe a couple of... I'm just kidding. Get some pollen in your system and you won't hear anything. Maybe perhaps we could shut that door.
Yeah, that would be nice.
Hello, can you shut the door for me? Thank you. Well, let me know if you can't hear me, because I can't hear me. So, I mean, I can sort of hear me, but you know, my ears are kind of stuffed up. It's allergy season. Yeah. Okay, good. If you can hear me, that's all that matters. All right, so let me talk about the Linux kernel for a second. It works as a HAL, which is a single monolithic kind of computer. Single computer device. Single kernel module that runs the entire system, just like any ordinary computer. We have device drivers that are not kernel loadable, but there is kernel loadable support. Depending upon the version that you're working with, you can actually swap out some of the modules, just like you would actually on a regular old kernel. Memory management, processor management, networking, all, believe it or not, practically identical, standard Linux. So your TCP is supported, your IP is supported, your UDP. You can create a UDP application, a TCP application that works on that phone, same ways it would work. In fact, if you're writing one of these customized, and this is very popular right now actually, instant messaging or chat programs and things, you know, to work on a private server, you know, you don't want to use Yahoo or something or Google. It's really easy actually. It's a UDP application. Or you can actually do it as a TCP if you want to, but most of it is done in UDP. So, if you're not familiar with UDP and TCP or networking, don't worry about it. You can get by with limited background. In fact, I have a lecture on it as we, not today, but as we get through the course. This is the part that usually opens up a few eyes for a lot of people. You can use C and C++ libraries. You can program in C on this thing. The interface for the Dalvik, and let me go back to this component here. This is made to work with the core libraries for Java. And what we're writing is Java runtime environment programs in Java. However, you don't have to do it in Java if you don't want to use this runtime environment. You can write a C program. that uses the libraries. You can write in other languages, scripting languages. For this particular course, we're going to focus on the Java, and the interface is through Java. But you don't actually have to, is what I'm saying. It supports C and C++ libraries. Interfaces through Java for the JVM, the Delvik environment. And we have surface managers handling UI windows, UI control, 2D, 3D graphic capabilities through OpenGL that's implemented through Java. So the libraries are actually using OpenGL. And they're actually using SQLite, and they're using a lot of the other built-in library features. In terms of the libraries, this is kind of the core, but not inclusive. We have more libraries that are not listed on the slides. Thing here. We also have other things like web browser engines and stuff like that. That also works. In terms of the runtime, this is what I was talking about before, the DVM. The deck file is sort of like the class file. Well, actually, sort of like the jar file. It's taking and creating a different file format in Java. You don't ever have to worry about this. Eclipse is going to do it for you. In fact, Eclipse is going to give you an APK file, which is an application file. And the APK file gets copied over and put on the phone or the device, and then that runs, essentially. So you're looking at one program, kind of like C or C++, actually. You have one program that runs one file that runs the entire program. And inside of that file contains all the different packages and all the different information that you're running. So compact, efficient, then class files. There's no more. If you write a Java program, and what we're going to see in the Java class coming up is we're going to have like multiple different class files. Not the case. This is all packaged together. And it's done for you automatically through Eclipse, so you don't have to worry about that. The core libraries themselves is actually supported with 5 or below. We're on 6 or 7. This is the JDK version. If you've installed anything from the last couple years, you're on a version that works. Some of the earlier stuff had different I/O, had different interfaces, had different core libraries. Maybe not 100% compatible. The runtime environment itself are the core libraries that are compiled for Android, which are the same libraries that you would develop on for other systems. It's just that they're optimized for I/O and things of that nature on the Android system. The application framework, we're looking at creating the APIs. And this is the part that if you get this, you get the whole entire platform. When we create an object to do something, we're making an instance of an API object. As an example, let's talk about, you don't know what an intent is yet, but let's talk about intent object, which is part of the application framework. You create an instance of an intent, or you create an instance of a content provider, you create an instance of a web browser or something. That's part of the framework, and you run the methods on the instance. In the Java class, you're creating your own objects, and you're primarily focused on learning object orientation. You take that as the predecessor for this class, and what you're doing is now creating other people's objects. You're creating objects that are application framework components that work on the DVM, that are, let's say for example they're part of the location manager. So you say, location manager, my new location manager, equals new location manager or something, and then location manager dot find location manager dot this dot that, and you're using the built-in functionality of the instances of the objects that you're creating. Your Android program is nothing more than a bunch of instances of objects for the framework, and mixed in there you have your program. Now what's your program? Your program are your class files. So the programming is the same. You have a class pencil, class whatever, Fahrenheit, or excuse me, temperature, and then you have a driver program. Your driver program, for 99.9% of what you're going to be doing the first couple weeks, is an activity. What's an activity? Well, we actually have 4 to 6. They're listed on another slide. I can't remember all of them. But there's different application types. So we have programs that run like services. They run in the background. We have programs that run activities. 99.9% of everything you're going to do is an activity. Well, it's an activity. You click on it, you press it, you start the program somehow, and there's a life cycle to the program, and it performs an activity. So you click on, or you press the icon, it says start my program, and the program runs, and then the program gets loaded up in the memory. It does an activity, performs something, and then the program goes away. Program shuts down. Or maybe the program doesn't shut down, it just sticks around for life, which it could do. So there's an entire life cycle that's associated with the activity or with the program. Each program runs in its own program space, and there's only one process per program. So if I created hello world activity, and hello world activity brought up a screen that said hello world, hello, and if I had, let's say, another screen for another activity, I would unload the first the application would unload the first activity in the same process space and reload the new activity and keep swapping stuff out. Rotates around through different activities and different functionalities, all in the same process. It's not multi-processing, not multi-threaded, which is interesting. Although we can have multi-threads and multi-processes, but only one of them runs at a time per activity. So it's kind of process abstraction is almost the same, except for it's simplified. It's a lot easier, actually, because you don't have to worry about swapping and having process synchronization. There's no synchronization. One program only runs with one process. And so the entire environment is secured that way, because one single process can't access other processes, which is interesting, which is why we make instances of content providers, instances of location managers. We can take and create a brand new instance. We have content providers on the phone. Content provider is giving us our address book, it's giving us our telephone stuff, I don't know, content. We can make an instance of it and create a new object inside of our program and access the features of it, but we can't go directly out to another running process and use that, which is weird. It's really a highly secure environment. One process can't go out and look at another process. Each database that you create is per process, per program. So it's not like database programming, you know, like when you create a database that's being used by all of the applications in the company and all the applications are connecting to it. So it's SQL-Lite. I mean, it's a light database. It's not a memory intensive. It's a very lightweight. It's automatically built in. The database is running as a feature on the framework. Each process has its own secluded access to the database, has its own login, its own, whatever that program does is not accessible by anybody else, just that one program, which is kind of interesting because the first thing people try to do is they create database applications, you know, or they create new content providers or something like that, and they try to share it among multiple applications. What we get is a lot of I/O. What we get is a lot of programs that go out to the web, or go out to a location on the internet and get information, send information. And we'll have an entire lecture on access, or I/O, actually, if you want to call it that. But it's content. I mean, you're either going to put things in files, you're going to put something in a database, you're going to put something on a web server. You're going to exchange information, you're going to pass it back and forth between programs from some shared memory location, or some shared thing, not the database, but some shared, like, files are popular. However, here's another interesting thing. If my program creates a file, it can't be shared with anybody else either. Only the programs, only the program that creates the file is able to use the file. And everything is actually sorted out and kept separate per process. And the security is the underlying issue right there. Everything by default is turned off completely. So we have this thing called the Android manifest, which opens the door for us. It still won't open up multi-processing, but it will open it so that we can send the file out, read the file, write to the file, and we have to actually provide a permission for the program to access files, the permission for the program to access the database, the permission for the program to access the internet, everything imaginable, you have to put a permission in there. So most of what we're going to be doing in the course is figuring out, well, what permission do I need to provide, what instance of which object do we need to create, and what method are we running on this object. And then we have these itsy-bitsy little things called API keys and other little restrictions that Google does to kind of make it safe again. You know, like your API key as an example restricts, it identifies your device on the network, so you can't like tap into other people's devices for GPS stuff like that. There's keys for almost everything. A lot of it's automated. Some of it's kind of manual still. Everything, configuration-wise, is done in the manifest. So that's the purpose of the manifest. We have the API interface, which is part of the framework, which is what we're creating objects of. So we create a new object of the location manager or some telephony manager. Activity manager manages the activity lifecycle. And the activity lifecycle is kind of interesting, and I got an entire, I'll wait for the next slide set on this because I think the diagram in this one is a little skewed, but we'll see in a few minutes. In terms of applications, we have built-in and then we have user apps. So when you buy the phone, you get built-in apps normally. In fact, even your emulators will have built-in apps. You can take all that stuff off if you want. If you do, you might be missing something. Like if you take the address book off of there, then you're missing content you can't really work with. So I would leave the content on there, existing content. Now you can replace, you can rebuild those apps. So Android application programming, you can take off the default mail client and put a brand new one on there, yours, if you want to. You're going to take the web browser off and put yours on. So there's no restrictions in terms of replacement of default apps. You can remove everything. You can actually disable the functionality on that phone quite easily by just going through and removing all the apps. However, what you're going to find, and actually Verizon is a really good example of this, they lock it down. So you can't remove it, even if you don't like the whatever MP3 player program by Verizon, Vcast this or something of that nature. I have a Verizon phone, which is the only reason why I know this. You can actually hack into it, remove the stuff. It's easy, but it's by default they don't want you to remove it because it's branded apparently. So I don't know. It takes up a lot of memory, and there's a lot of stuff on there I don't use. But you can always access the phone from a mount it like a thumb drive or whatever, and go through the file system and remove stuff manually if you want to. Some of it actually is protected though. So what we end up with are application building blocks, and here's my little list here. We have activities, we have intent receivers, we have services, content providers, and this is a little bit of a list. I'm going to kind of go through these 4 to start out with. There's a few more things that we can actually talk about as well, but I will see them as we go through. The first couple of assignments work with these guys. Work with activities, intent receivers, services, and content providers. So activities, which is kind of the easiest one of all of them, and this is the hello world that we're going to create today, typically corresponds to one UI screen. We have a screen that comes out that says hello world. It's an activity by default, but they can be faceless. You don't actually have to have a screen for your activity. It could be a background process. It can be a floating window. It doesn't have to be a fixed window. And it can return a value. What is it going to return it to? Something else that's going to be used in another piece of your program, another activity. So what we'll end up with is your default class, and your default class will have the word activity next to it. That says we're a hello world activity. And the reason why that's on there, and I don't know why they kept it on there, but the reason why that's on there was to tell you that you were using the default. And of an Android project type, default is activity. Activity means nothing more than the description of a class that loads a UI, and the UI just sits there and does something. Maybe a calculator is a nice UI. The UI can also call other screens as well. So, and you can have multiple activities all in the same class if you want to as well. Excuse me, all in the same project. Each class is defined as an activity in the same project. Intent receivers corresponds with response to broadcast intents. Broadcast intent. Well, when a text message comes into your phone, you've got a receiver. You have a broadcast receiver that comes in and says, "Hey, we got a new text message." How does your phone know which program is supposed to open that up? Well, you make new instances of intent receivers or broadcast receivers or intents themselves, and you say, well, if this happens, open up that program. If that happens, open up this program, and you have that program running, so it knows, it listens, and it says, oh, look at that, a new event has occurred. We have a new text message, and open it up and read it or do something. Way to respond to external notifications or alarms. I use the text kind of incoming text as a notification. It's a form of a notification. We actually have notifications that come in as well. Classic example is when you've installed an app and your app's provider goes back and says, hey, you know what, there's a new update. Let's notify you of that. Or maybe you've got a calendar and the calendar comes back and sends a notification. So you can actually create a new instance of the notification object and create your own notifications. So every 5 minutes the phone tells you, hey, it's time to go to lunch or something, And then the app can invent and broadcast their own intents. You can actually define your own intent that's going to be used in your app on your phone to do something. So, and intent is interesting. And the word intent is kind of, in terms of the context of Android application development, is something that you just have to kind of take as a definition. And I don't actually have a textbook definition for it, and I haven't really been able to find a nice, easy to understand textbook definition of it either. I always think of it as more along the lines of one person telling somebody else to do something. Your intention is to walk down the street. Okay, walk down the street. Okay, and your intention is to, so everyone has their own job, their own role. So when one intent is created, it sends information, let's say, from one sub-process to another sub-process, but only one process is running at a time. So the intent is to load this screen. And then, in fact, I have a nice intent example that I'll show you. That's a program that has two screens, A and B. When you press a button, A loads B. When you press a button on B, it loads A. And A loads B, and goes back and forth loading these two. What it's doing is it's running an intent. And the intent is it's like event-driven behavior almost, but it's not. It's like telling somebody to do something. Tell page A to load, and A tells page B to load. And that's how you multitask and switch between different parts of your program and activity. So one activity sends an intent to another activity. It says, hey, start. And I'm going to end. And so you have intents that start, that end, and then you have another intent that starts and ends. And you can have multiple XML screens that work with each one of the intents. And the XML screens are the UI that work with the classes. So you have multiple different activity classes. You could have different types of classes, as we'll see, that aren't activities, that load and unload intents and call different intents, which is how you create it's how you create the multi-processed program, multi-threaded without using threads. So it's hard to, I don't know, if someone ever finds a good definition of it. Here's an intent. Let's see what this says. Think of intents as verbs and objects. So, description of what you want done. View, play, call. I don't know. It seems kind of it's a word that only comes in it doesn't even exist on the iPhone. It's an Android term, and it's only because Androids don't do multiprocessing. Only one thread it runs at a time. So your programs use intents instead, which is safer, cleaner, and faster if you think about it in terms of the implementation. So an Android app actually could run a little faster than an iPhone app, depending upon how it's designed, if it's designed correctly. So system matches the intent with the activity that can best provide the service. Intents can load up mail programs, can load up, your program has something and it needs to send a message out. So the program stops, runs an intent, loads up the mail program, sends the information to the mail program, and then the mail program sends the message back out or whatever, and then the mail program calls an intent that loads your main program back up again. So you're switching back and forth between programs to send something out. Activities, intent receivers describe what intents they can service. So intent receivers, I'll leave broadcasters and receivers for a separate lecture of its own because that does definitely merits a little bit more comparison. But I won't do that for you right now. Here's an example of intents used with the basic features of the phone as an example. We've got home, contacts, Gmail, chat, blogger, I don't know, just a bunch of stuff, right? System picks the best component for that action. Let's say you opened up your contact list and there's a photo. It's going to use an intent to go over and open up the photo gallery to show your picture that's going to be in the contact list. And then when that's done, the intent's going to come back and open up the contacts again. So you can kind of think of the intent as like the traffic guard, actually. And it's going to register. You can register intents, and you can actually use this program. Oh, you might have 5 different photo galleries on the phone, but you want this one. And so it knows which one it wants because you tell the intent which one to load. And then you can load a specific one. In this particular example is picking a photo from Gmail. So the client component makes a request for a specific action, and then the action is performed using the intent. New components can use existing functionality. Every program that you write can use existing functionality through intents for existing features of the phone. Only problem is you have to make sure you have the right information on here. In fact, some of the stuff for Google Play, some of the Oh, the text-to-speech, some of the really cool libraries. You'll actually get some automated behavior. If it doesn't exist, the automatic error checking comes back and says, hey, would you like to go to the Google Play and download it? And it'll actually automate the process for you. So the content provider is actually giving you whatever the intent is actually looking for in terms of the functionality. So that's intents. And we have services. Services are different from intents. These are faceless components that run in the background. Music player, network, download. It's just a process that never stops. Runs as a service. Background process. Content providers. So content.
Questions about services?
Uh,
If each app can only run one process,
ah.
how
So you have multiple programs running. So you create the service. You have two programs instead of one. So the service is going to run because once you start the service, you can't get to the UI. So you start the service and it's almost a separate program. And the intents are used to communicate with your app A to the service or app B. So you're actually creating two apps is what you're doing. And both of them are running simultaneously. Because think about it, you can run as many apps as you want.
so as long as I know go back to services and
Yeah, and one of them is running as a service, essentially. So you have that service. What's the service going to do? Service is going to basically play music, I don't know, download something. You have services that are built into the phone, like the download manager, and music player actually runs as a service as well. Your program can have, you can create your own service, it can run, and then the service can stop, interdependent with whatever else is running. It is running simultaneously, but it's not a multi-programmed program, if that makes any sense. It's two different programs. Yeah. You see, you have to just like break the logic out and say, well, this is going to be a service, and that's going to be this. And your app is essentially, when you put the app together, you could pull it apart, have this component, this component, this component, this component. And so in terms of the design, if you map it out, kind of like a storyboard, each one of the components has a separate functionality to it. It's a self-containing running program that can just run on its own. And your intents are switching back and forth, starting the service, stopping the service. What ends up happening is people write apps that have services that start and don't end. And then you go, well, how come the battery is draining down on my phone? It's because, you have these services running. So
just idle.
yeah. Well, no, the services, depending upon the quality of the app you're using, where you got it from, you could have apps that actually drain battery automatically because it's loaded a service. It's not using the service anymore, but it didn't unload the service. It's like a runaway process that's just running forever. And there's actually apps that you can install that catch stuff like that. So you can easily write an app that actually looks at the running services. It's kind of like Task Manager, and you can just delete anything that you don't want running. Yes?
If I run any app, if it has 4 or 5 services, all the services will be started automatically.
It depends on when you start them. You actually have to make a new instance of the service object and start it. But the app is going to control the service, starting and stopping. And if the app goes away and the service is still running, you've got a daemon process. You got something that's going to run forever. There's not too many apps that will do that because there's now checks on most of the current modern versions of the APIs. Will put timeouts in there. So the service will come, this thing is running, do you want me to quit? It's still running, do you want me to quit? And they go, oh yeah, I'll quit that thing. And so sometimes it gives, or sometimes it just ends itself automatically from a timeout. And you can set a timeout on a service. So, and we'll look at that one. We'll create an app that has a service in it, so you'll see that. Everything is a content provider. Content providers give us our content. Enable sharing of data across applications. So address book, photo gallery, everything runs as a content provider. Nothing more than saying, it's not a database, but it's nothing more than saying shared information. But you make an instance of the content provider and you work with it in your sole environment. You can't actually take a look at what another process or another program is doing with the content provider, which is kind of interesting. So going back to that, you can access all of this shared information on the phone, and this is how you're going to share stuff. So you're going to use the address book. You're not going to create another address book. You're going to use the content provider. So everything is sort of linked together via the content providers. So it provides the APIs for querying, deleting, updating, inserting. Different than databases. Don't confuse this with a database. Databases are not content providers. They are only used for single applications. They're not shared among all the different applications. Neither are files. Files are separate per application. Content is represented by a URI or a MIME type. I'll get into that when we start creating instances of content providers. Create a new URI. And we go and we look at whatever's in there. We add stuff, delete stuff. So development tools. Eclipse, we know that. This is the part I'm going to kind of skip through because we're way past this stuff already. 2.0, yeah, it's a little higher than that right now. Emulators, you guys all have emulators installed, I hope. Some of you may not have them yet. This is outdated. The newer emulators actually do support the camera. The original ones never supported the camera. Actually, some of them didn't support the internet either. Now they support internet access, cameras, databases, everything. Obviously can't run the GPS without the debugger, and we'll show you that, but runs the same image as the device. Yeah, devices come in different shapes and forms. In terms of the hello world, which is what we're going to do next, we're going to do assignment number 1 to get started. It's not bad because it gives us a run through on Eclipse and gives us a run through on activities and stuff like that as well. And there's a lot of reading in that hello world, and I'm not going to read it to you. You can read it to yourself. But the concept of the UI and the views is important because it gives us our building block. If you think of the concept of application development for anything, even for a computer program, it's all the UI, isn't it? The entire application is based on the UI, whatever the UI functionality is doing. So it's very event driven. So getting familiar, really familiar with the UI, it will be very helpful because then you know which component to use. Because just like on the iPhone, actually, the UI components are assembled to create the illusion of a wheel or to create the illusion of a flipping page or something, or a multiple list or a scroll or something. You're putting building blocks together to create your, fascinating interface, whatever it is that you're doing. So we have different things that are laid out, and there's an entire hierarchy to the layout. So it's placed in the concept of a layout. We have a main layout, and inside of the layout we have nested sub-layouts or sub-views, which is different than iPhone, which is kind of interesting. So linear layout, table layouts, absolute layouts. This is more swing associated than anything else. So if you ever ventured out into swing, then you'll like the UI because it's the same. I mean, it's very similar in concept. If you've never heard of swing, after you do this stuff, you go, oh, swing is easy. This is a little bit more complicated, actually. The subviews are a little bit more tricky. Because, you have this canvas you're working with, and you're going to divide it out into different sections for different things, and you're manually putting all these pieces together to create the illusion of, the tabs and the pages that are flipping and everything else that's going on. So, in the iPhone, you've got libraries of components, and you're making instances of objects, and you're just dragging and dropping, and they're all controlled independently. Android, they're all controlled together. So you can apply one method call on one layout and have everything disappear completely. You can do the same thing on an iPhone, but it's a little harder. So it's kind of interesting how one of them they both have their pros and cons, let's just say that. I actually prefer the Android better. It's a little bit, although it's all controlled together, if you're a control freak and you just like things to be in order, you'll like Android a lot better. If you want easy, lucky go, whatever format, then the iPhone is more up your alley in terms of the UI. But we'll look at layouts and all the different absolutes and everything as we go through the course. It's one of the things we look at is the UI. Application lifecycle, which is kind of interesting. This is the one I'm not quite sure. Here it is. Here, this picture is not going to come out, so I'm going to show you a picture in another lecture that's actually that's skewed correctly for the screen. In terms of it, we have applications that run in their own processes, as I mentioned before, their own VM or PID, process ID. We actually can get the process ID of their own process. Processes are started and stopped as needed to run application components. So the process itself can stop and load something else, and then it can stop. Processes may be killed to reclaim resources. Other things on the phone will kill your process if it's eating up too much resources, which is kind of interesting. So we do have some process intercommunication, but in fact, here's where I'm going to switch over to that other one. I have a better life cycle picture to show you. And I want want to say it's lecture 3. Let's just see. I'm switching to another lecture that has a better picture on it. If I can find the picture. I'm not going to cover this whole lecture. I just want to show you the life cycle. Here it is. And then we'll go and work on assignment number 1. Activity is one thing you can do. This is the activity life cycle of your basic program. I'll make this a little bit bigger. This there we go. This diagram actually is worth an investment of looking at, because then this makes a lot of things make more sense. Because the entire structure of the Android program is developed around this life cycle. Everything from the onCreate method to the onStart, which is the basic component of the activity class, is geared towards management of this life cycle. So by default, every program that runs as an activity, the class will be labeled activity, so you know it's an activity class. By default, it's kind of like C++ and C or Java with main, the driver program. Well, main is supposed to be the starting point, kind of, you know, the entry. In this environment, onCreate is on the instance, which is sort of similar to a constructor, which is kind of interesting. So onCreate means when the new instance of this object is created, when my application starts, onCreate is going to be performed automatically. If you leave out an onCreate method, your program is not going to compile correctly. It's going to say, hey, we're missing an onCreate. If you leave out some of the other stuff, it'll work just fine. We don't need an onResume, we don't need an onStart or onFreeze or onPause. However, that's going to tell us all of our different life cycle states that we're in. Because we start at the beginning, we get created, and this is the instance of this object that we're managing this life cycle for. Our onCreate happens first, and then we have an onStart optionally. We must have the onCreate, everything else is optional. On a start, it might be a service, it might be something else that we're running, that we're checking for on parameters or something. We're always going to create. You know, that's the constructor. We may not necessarily start. We might do an onCreate and not start. We might stop at this point. And it can be used for error checking, you know. On a start with, you know, what if we can't get a network connection? Are we really going to start? You know, so it can be used to control the state of the onCreate. OnResume is when the program is paused. We started, we created, we're always going to create. We started, which is kind of optional at that point, but we passed through the start stage and now we got paused. So now we're going to resume. So you can create the onResume to exit if you wanted to. So the program never gets paused. And I actually have an example we're going to do to see this work. But let's say we made it through the onResume. You know, maybe we just passed through it because we didn't ever resume. We have an activity that's running, which is this green thing in the middle of the screen here. Our activity is running. We're performing something. We're doing something. We're showing a UI to the user, perhaps. Then we have a new activity that's started. You know, something is displayed. We can also check for a freeze or an on pause, which is like sort of the on resume. So if we have a resource open and we're going to pause, we can set the on pause to close the resource, to conserve memory or something. And then on the on resume, your activity comes back to the foreground. On the resume, we can have the on pause turn something off, the on resume turn something back on. You know, maybe it's an internet connection or something. So we can kind of control these guys together. Your activity is no longer visible. We have an on stop. Just because it's stopped, it doesn't necessarily mean it's done. That's the on destroy. On destroy cleans it up completely, makes it done, and then the activity is shut down, which is the endpoint. So if you think of this sort of like the life cycle of a process, which is kind of a hybrid between a process life cycle and an activity life cycle or a program life cycle. We have processes that are new. Well, they're created, then they're new. Then they're waiting, then they're running, then they're waiting, and then they're running, and then they're eventually stopped, or they're destroyed, or they're taken out of memory. We can control the way that the program runs by knowing what this is doing. And what ends up happening is you see a bunch of examples, and one of them will say on freeze, on pause. On pause, on start, it's pretty popular in terms of controlling intents and content providers and stuff. The on pause, on resume is to conserve resources and essentially make your program work friendly with everybody else. On a stop, you could do a on restart on a stop. Let's say you don't want your program to stop. And then you can, come back up and say, well, restart if you stop. And you can create basically a loop in your program. And then on this other side here, on the process which is killed, what we end up having is, destroy in terms of the on stop. We're basically going to do memory management. And so the user navigates back to the application and starts it over again on a create. So it's nice to be able to know which state your program is in. And I have an example, probably not till Wednesday, well, probably Monday. No, Monday's a holiday. Next Wednesday, a week from this Wednesday, I think we'll be ready for the program state demo. And we'll see which one of the states something gets into. And we can actually, kill it. We can actually see it. Because what we end up with is, even though we don't have multi-programming, we have signaling. I mean, we don't have multiple threads, but we still signal. The application actually signals to itself. So it knows if something was successfully loaded, it knows when it's stopped, it knows when it's paused, it knows when it's been put in the background. We need that because then we can make sophisticated applications that can play well with others. Not take up too many resources and do some pretty sophisticated things. So. Alright, so that was the lecture part of today. I'm not going to cover this entire one, I just wanted to show you that better diagram. What we're going to do now is the programming part of today, which is programming assignment number 1, which is basically too easy for you guys. It's way too easy. But some of you people don't even have the development environment installed yet. So this is assignment number 1, the same thing I'm doing for the object-oriented programming in Java class. I'm going through each one of the assignments because hopefully maybe you'll do them on your own this time. So not only that, but it's kind of a learning experience. So I want to teach you sort of like a tutorial-based thing. So assignment number 1 is actually kind of interesting. It's more of a tour through Eclipse, not really a heavy-duty programming assignment. When you turn your stuff in, you're going to go to the workspace directory, zip up your project, and send it to me. And everything we're going to create is going to be inside of the project. If you haven't seen this yet, it's just like, this is just like Windows actually. If I go into my home folder and I click on workspaces, I see that there is a folder here for, actually this is the one I did in the Java class. It's the same process, believe it or not, for object-oriented programming in Java. That's a Java project. Everything you do in Eclipse is going to end up in this directory. So you just take it, zip it into one file, and upload it into the LMS when it becomes available, or EMS I should say, which is how you're going to turn stuff in. This comes from bhacker.com. It'll also be in the LMS pretty soon. So I'm going to open up Eclipse, and I'm just going to do assignment number 1 for you. I'm not going to do the whole thing for you, but I'll do most of it. And then, because then I can talk about and show you the different parts of what it is you're looking at. And hopefully you'll be able to understand it a little bit more. I'm going to close this guy because we don't need him anymore. This was from the last class. And it'd be nice to know that this is more automated, actually. The on create's created for you automatically, which is nice. You don't have to actually create your own main or anything like that. It's done for you. And do not use the sample projects for the homework assignments because the sample projects are going to give you way too much information. And they're going to give you way too much. And another couple weeks down the road, we'll go through the sample projects. But we're going to start in with number 1 here. You can download this from the websites. If you can't see it, it's hard for me to zoom in and out, so I'll just I'll zoom a little bit and then I'll zoom it out. Create a new Android project. Okay, so you're going to open Eclipse, you're going to go File, New, expand it out, make it an Android. What do you call it? I don't care. You can call it Lab 1. I don't care. You can use Android 4.0 as a build target, or you don't have to. You can use any build target that you want. So don't take this as I have to use 4.0. Actually, in a couple years from now, it won't be 4.0 anymore. The name itself, the package name, that stuff like that, activity name, use anything you want. So let's take a look to see what happens when we go through this process. So I'm going to go New, Android Project up here. If you don't have this menu object, you go Project, click on the project, and then hit Android Project from here, assuming that you have all of this stuff installed from last week. You're going to be totally lost if you don't have it installed from last week. Next. If I click on next. And then what I was saying before is don't click on that sample project link because it's not going to help you. Give it a project name. I'm going to call this assignment number 1. I'll call it Android 1 just to be consistent with the other class. Keep everything on the defaults. We don't really need to do anything. I'm going to actually downgrade this to 2.33 here. It's the same project actually. And I'll tell you what the differences are in a few minutes. But it's the same, it's going to give you the same interface. So it just runs a little faster on my computer. In terms of the package information, and if you weren't in the Java class earlier today when I went over this, this is generally the URL backwards. So if I'm at itu edu, I go edu.itu, and I'm going to call this project 1. What is that? It's just the directory, and we'll see the directory location. Actually, you'll see it in the workspace directory if you click on the file folder. You'll see that actually out there. The minimum SDK is going to be determined, and then if you click on the list, you'll see it. This is the API version that I selected. So minimum is 10, which is a 2.3 or a 2. It's a 233, which you see it right here. This can be changed, but why change it if you automatically selected 2.33 in the beginning? So this really does the same thing as that first step when you pick the API level. If you change this API level, it will change the API level of your application. Why do you care about the API level? Well, if you have an old emulator, you want to use something that's older, so it's supported. Nothing is forward compatible, but it is backward compatible. So you can run a 2.33 on a 4.0 just fine. You can't run a 4.0 project on a 2.33 emulator. Not going to work. So it depends on your emulator version. I particularly like API level 10 because it was pretty solid. It's like one of the most solid versions, and that's the current version that's out on the market right now. Most of the apps, most of the old Android devices are running 2.3. So because it's solid and it works and it's pretty efficient. Okay, I'm not going to use the test project because I'm not going to use JUnit for this particular project. Instead, I'm going to see what this error is up here. And this one up here says, I can't put a space. I can't put that in there. So Android 1 activity is not a valid Java identifier. So I will change it. Actually, I'm just going to call this hello world. Usually this is put in automatically for you, and it usually matches the name of the project. It is the first activity that is created, and I'll show you what that looks like in a few minutes. Because I changed it up here and it changed it down here, it didn't like the dash, I renamed it. You don't normally have to rename this, however. It should automatically populate when you put the correct name in it up here. Okay, so now I'm going to hit finish, and I'm going to show you what that actually meant. Oops, except for up here, it's got that dash in there. I thought I renamed it. Okay, so here's an interesting thing if you want to, and I'll show you how to rename the project actually. It's not called rename, it's refactor. And when you refactor, you change the reference everywhere out throughout the project. So in this particular case, I wanted to call it Hello World. I thought I changed it, but apparently I didn't. I could delete this and start fresh. Or I could just try to refactor it. If I refactor it, what I'm doing is essentially, I'll just show you how this works. Right mouse clicking, and I'm going down to refactor. And this is on the bottom of the screen, so let me pull it up a little bit so you can see it. And I'm going to go into rename. If we move something from one directory location to another, we have to refactor it. If we rename something, this name will be changed throughout the entire project, wherever it references. But this is the project name, so it doesn't really matter. But I'm just going to call this Hello World. There we go. So I have update references, which basically says you're going to rename it every place where it's being referenced. Okay, so at this point, you can sort of see the directory structure. If we hit down here and never ever modify this project property, if we double click on project properties, this is where the target is going to show up as Android 10, which is my 2.33 version. Some people go in here and they change this. And then they go, oh, this file is automatically generated from the project properties, and it comes up from here, from project properties. And this is where you set the information. So if you don't like any of the options that you selected when you created used the wizard and you created that template that we just saw a few minutes ago, then you can come in here and say, well, this is the Android API version, the target that I saw, the 10. And so I can change it here if I want to. Or I can also change, the build directory or, any of the other information. I'm not going to mess with it, though, at this point. But if you go in here and you try to edit this file, which is kind of misleading because we can edit the manifest, no problem. But if we edit this file's not editable, which is kind of weird if you think about it. It's not very consistent. The manifest, however, if I double click on it, I get two versions. I get an XML looking interface, or then I get a menu kind of, fill in the blank kind of interface. And I don't see that unless I click down on the bottom. So this is an XML format, which means it uses tags for data. And so if I click down here where it says Android Manifest XML, I see the manifest code in here. Although this does say, and this is taking it from minimum SDK version 10, this is going to be, again, selected automatically from those choices I selected when I created the project. This stuff in here is all coming from the project creation as well. I can modify this. I can modify anything I want in here. I would leave, to begin with though, I would leave some of this stuff on the defaults. Only because you might mess up the way that your program is running. So as I was mentioning before, we have multiple different class files that we can keep and we can run inside one process or one program. And we can create multiple different activities and things of that nature. So we need to tell the manifest where to start. So the manifest knows what icon to use for the program, and it knows which class to start. And this is where it is here. So where we've got activity, we've got an opening and a closing tag. And in the activity, we're going to run .hello world activity. And .hello world activity is actually out here. This is hello world activity that we're going to run. And this is what's basically, so if we create another one, we have to change the manifest if we want the other one, the other activity class to run first. We have intent filters, and people go, what in the world is an intent filter? Well, everything runs in the form of an intent. So when we run this initially, we only have one intent, which is our hello world activity. We will eventually be adding stuff to the intent filter to say, well, we have this other activity, and we have that other activity as well. And we have, 5 or 6 different activities, so we list the different activities. It's nothing more than creating an entry that lists the class name. And we'll see that coming up when we look at intents. And then we're allowed to switch between the different intents. We're allowed to switch between the different activities. If we don't put the activities in the manifest and tell Android that we're going to use these activities, we can't switch between them, which is weird. And that's what the intent filter is doing for us. It seems like it's something else, but it's really registering all of the different activities that belong to this project. So if I go out here and create another one, I have to put it in here. Right now we don't have any. This is pretty much empty. In fact, I could take this out and the project would work just fine. But the action main and the launcher is just the default, which is going to be up here, the main activity, which is going to be our listed activity with our string for activity name. And then the next thing that people wonder about is, what is all this string stuff? And the string information is all kept in a file called string, and it's in the resource directory. So I don't believe I've gone through this whole test drive through the project. But another thing you're going to look at a lot is this resource directory. And the resource directory in the values, now why do they just call this strings? I don't know. But it's called values. In the values you have yet another XML file. And the XML file is called strings. If you double click on that, it opens it up on the right hand side. And again you have these two different versions again. So if you go down here and you click on strings.xml, you see the XML code. Some people like this interface. Some people like this one. I sort of like the XML interface because then I can actually kind of see everything all at once. So if I click on here, I can say I have two strings in here by default. I have the string that's for my application name, and then I have this other string that's going to say hello world activity. So I can just leave them alone. Theoretically, what you need to do to make things efficient is in the layout use the strings, because it's kind of like when you set like region or you set universal access. If, let's say, for example, I wanted to create this version of the program to work in Spanish or French and not English, I'd have to go through every single one of the user interface screens and change all the words around manually. A lot of work. If it's all done in strings, and I have multiple different, I have a French string file, I have a Spanish string file, and I just switch the files. In fact, the user can switch it. You know, a little button, little flags on the top. You know, it's just switching between string files. And there's a definition for each one of the words in every different language. And you use the strings inside the interface, and it automatically sets it for you without having to hard code it. So that's what the string. That's one of the advantages of the strings. The other ones is it makes it more efficient. Makes it more like you can't misspell it. You know, it's an application name or something like that. So. Alright, so the other one you're going to see by default is called layouts. These are actual directories, and the layout's got main.xml, which is going to be the main layout for the program. If I double click on it, it should open it up on the right hand side, and it does. This is probably the most unfriendliest screen I've ever seen in terms of the interface. So the UI builder on the Apple definitely does a much better job than this. There are some buttons on the right hand side to make things bigger, magnifying glass to make things bigger. Depending, I have this zoomed out, but apparently, most systems it's too small. You have to make it bigger. If you look at the palette on the left-hand side of the screen, you see form widgets, and if you click on the items that are supposed to open up, it is opening up. It's just running a bit slow right now. You can open up the different categories, and you're dragging and dropping. As an example, here I've put a button on my interface. And if I double-click on the button, it'll take me to the XML interface. And again, I have the option of doing everything with the GUI or with the XML. Most of the time, you're going to be in the XML interface because it's really hard. It's really hard to position things through the GUI. So here I have a button text, and I can change the text here, or I can use a string. This is what I was talking about before. If you use a string on there, then you can change the string a lot easier. So, but I'm just going to be lazy. I'm just going to put here my button. So I put a button on here. And the button has an ID, so programmatically I can get at the ID of the button by its ID. So I go in there and say button, you know, button ID button1 dot set text to my other button or something. And change the name of the text through the source code, which is what the ID is all about. The other information that's stored with each one of the GUI elements is characteristics about the GUI element. For example, the size of the field, the size of the button, whether it's left align, right align, and stuff like that. I've got an entire lecture on the UI interface. However, you can kind of sort of see the default here in the way it's organized. We have a layout, and inside of the layout we have these components. And each one of the components is a separate XML entry. So the layout is a linear layout, which means everything is in a line, and it just word wraps. I actually prefer the absolute layout, because then I can say, you know, put this button to the left of the input field, and things are in relation. They're relative in absolute relativeness to the other components, or I don't know, I can't remember how that works. There's a relative layout as well. There's an absolute, there's a relative, there's a linear, there's a grid, there's all sorts of different choices that you have, and the only way you learn them is to experiment with them, really. But by default, you get the linear layout here, and the linear layout is nothing more than, you know, it's going to fill the parent. So this means I can actually have more than one layout that doesn't fill the parent. You know, I can have like the top of the screen could be a certain layout, the bottom of the screen could be a certain layout. That's why I say if you like swing, this is way up your alley. Kind of similar. Not for non-swing people, it's not very intuitive in the beginning, but then you learn it. So when I have an item here, this is a text view. That's a label, aka label. The text view is going to show you text. The button I just put on there. When I go back out here to the graphical layout, anything I do here is reflected. As an example, if I take and put another button on here, automatically when I go back into here, the other button's on here as well. If I delete this button, this is that second button, I'll get it removed as well. So I come back here and now the button's gone. So it's the same screen, it's just two different views of it. And you might notice I have this little handy dandy message here that says, well, how come you didn't use the string reference? It's because I was lazy. So hard-coded string, my button should use a string. Okay, it's a warning message. So you'll see the little warning over here. Okay, enough playing with that. Let's get to the assignment. I want to save the changes. Sure, why not? So most of the time you're going to leave the manifest alone, and you're only going to change the manifest when you have to add or subtract permissions, or do certain things with intents and stuff like that. So what we actually just did was step number 1. We created a new Android project. Step number 2, take a tour of the application. This is your reading. You can read this stuff on your own. What you're going to do is look at each one of the files. I'll briefly kind of take a nice little tour through this thing actually to show you what I was lecturing on today. By default, we get Hello World activity. If I double click on Hello World activity, lo and behold, I wasn't lying. I get an onCreate method created for me automatically, which is equivalent to the main, actually. Never, ever, ever delete this. This is a source of issues. You cannot, every activity has to have an onCreate. If it's not an activity, you don't need an onCreate. And only one onCreate method. So just take it as de facto standard, never delete it. It's kind of like deleting main out of your driver program. It's not going to work. What do we have here? This is the kind of confusing things. Like, why do we have to include Android OS bundle? We don't actually have to. I can pull that out of there. It's like including iostream.h or something. But it's in there by default, which is not bad. And now we see, in terms of our Java, we see actually more proper Java than we do in that if we just create a regular Java project. Because now we have the package, edu, itu, project 1. When we put this up here, because we want to put all of the files that we're going to create have to be in the same package. So because that has to be the case, it's going to be put in there automatically for us. We can get sloppy and take the package out, no problem. Only thing is if you move it around a little bit, you're going to cause some confusion. It may or may not compile for you. So every program that you create, so you create a new class as an example, make sure to put the package on the top. It's basically just telling you to put it in this directory. And the directory is given for us right here as well. So if we forget, we can always put it in. What ends up happening is people will download and cut and paste and put examples in here, and all of a sudden they'll see like 5 different packages. And like, what's wrong with that? And then you start pulling this stuff out, start taking it out, and all of a sudden the packages go away, and you basically have confused yourself at that point. But so these are our imports, just the same as Java and regular old importing libraries. Right here are public, and it has to be public because we have to be able to access it. And this is the activity class, and in the activity class is equivalent to our driver. So this is our driver program. So we can create other classes and make instances of those objects in this class if we want as well. So called when the activity is first created, we have the onCreate. Leave this alone, the bundle saved instance state. This is what's giving us the feedback. So when we create the activity, the runtime environment is going to come back and say, okay, 0, 1. And then we know if we're paused, if we're resuming, if we're starting, and we can keep track. We don't actually have to send it. This bundle, actually we can create new bundles, and we can actually use this to keep track, and I have an example that's going to do this in a couple weeks, to keep track of the different states of the process, so we know what state we're in. Why do we need to know? We just assume, naturally we just assume that we're started. We just assume that we're stopped. The super onCreate, for some of you guys that were in the in the object-oriented programming course, super means the same thing, actually. It's going back to the class that started this class, and it's running the onCreate for that class. In Android, we actually, in Java, without Android, we can actually just go like this, super. Or we go this. Yeah, we learned about this today. Can't do that in Android, because there's an assumption that this is the main class. It's going back to something, but we don't know what it is. So whatever created us, so we actually have to call the onCreate or whatever created us. So the syntax is slightly different. The meaning is identical. So we call onCreate from super. What does that do? It just creates, it runs, and this is, call this the constructor. It runs the constructor from the class that called us, or that made us happen. It might not be anybody, usually isn't. But if you leave it out and then you start inheriting, you're going to run into problems. So put it in. Set context field, well that's an interesting new method. So our activity class, because we are actually doing hello world, we're inheriting. We're inheriting from activity. Activity has a method called set context view. We can say this dot set context view, but we don't actually have to. But this instance of this object, we need to set the context view. And we're like, what in the world is that? Interesting thing is that we have multiple view concepts in Android that we don't get in regular old Java programming. And so we can have, and this one is called an r.layout, and I'll explain that in a few minutes. But the one you're paying attention to here is the word main. And main is actually this main out here. And if you capitalize this, you're going to get a type. It's not going to work. And if you change this name, you have to change it here. This is actually, believe it or not, the package location. And R stands for resource. Why they didn't just label this R? Because the older APIs had a big old R, which is I thought was a little easier. And then they went, oh, but people, why don't we just call it resource? So yeah, it used to be called R, and then we had layout, which makes some more sense actually in the directory structure. And then inside of layout we have main. So we can actually change it. We can take layout and make it, my layout, and then just put my layout here. But no, most people wouldn't do that. They just leave it alone. The R resource gets pre-compiled, and it is created for us automatically in the generation folder. So GEN, which you're never going to touch. It's automatically generated for you. You're never going to touch this. This is how the XML code turns into Java code, because the entire program runs in Java. The interface to the layout is in XML. It gets converted. So it gets converted. It gets converted in terms of the r.java file. Excuse me, r.java is it's the compiled version of the XML put into Java. Never touch it. You don't have to do any of this stuff. It's automated for you. People get into trouble when they start editing this. You never have to include this either. This is automatically included with the project. If you have the XML file on there, you have the r.java. Because, yeah, if you have a problem with that, cancel the program, scratch it completely, open up a brand new project, and start fresh. Because you're never going to get out of that error message. That error message is deadly. Because you can't mess up the auto stuff. It's just the same way as editing your project configuration. If you've done that, throw the project away, start a new project. Not worth it. Build configuration is also a version of the project that is compiled, but this is the project properties that is compiled into a Java format. So everything has to be converted to Java. So all of the XML stuff ends up with automatically generated Java compatible. However, it doesn't happen instantaneously. So sometimes you'll see a red thing. You'll make a change. It doesn't actually automatically update constantly. It just every so often it kind of syncs and checks and stuff. So, and in my opinion, it doesn't do it fast enough for me, because I always see this real red stuff, and then I just wait a few minutes, and the red stuff goes away. Oh, okay, it sunk. It made it. There's no way of telling it to do it. There's project fixing, and you can come up here and go into the project folder and say clean. What does clean do? Actually, clean goes back and repairs. There's a repair, and it just syncs. It automatically forces all the auto generation stuff to work. So let's say, for example, I didn't want to clean all projects. I wanted to clean specific projects. I can go over here and say clean. It's going to go back automatic. Let's say it closed it because it automatically generated it for me, and it's not in sync anymore. So it just. So whenever you see red stuff and you're, oh, it should be right, but why isn't it syncing? Clean it, and it'll automatically reset everything for you. So you shouldn't really have to clean. But if you have a slow computer, that might actually be a problem. So, okay, so going back to Hello World number 1, we have the tour that you're supposed to take through the project. So the tour of the application, we looked at this file right here, which is called Lab 1 activity. Ours is called something else. You're never going to touch this directory here. This 4.0 is actually this one here. You're not going to touch this one either. This is your base APIs, your Android.jar files. In your Android bin directory, you have a bunch of, actually it's the lib library directory. These are the same files that were installed when you downloaded and installed the SDK. This is what they're talking about. You're never going to touch this one. Assets you might touch. Assets are used inside of the program. If you're going to have a file, if you're going to create a web browser and you want some local HTML files, let's say, you can put them in the asset directory, and we'll see that throughout the course. Anything that the program is going to use that's going to be stored in the home directory comes out of assets. So text files, web files. Bin you're never going to touch. That's the auto-generated files. If you go into bin, you'll see resource. I don't have anything. Nothing was compiled yet. As soon as you compile it, you'll see a .apk file in there. And I'm going to try and remember to bring my device, which I haven't brought yet. And I'll show you how to take that APK file and copy it onto a device and see that it's the running program. So there's many different ways of installing it. It's a little easier than the iPhone. But I will put that on my to-do list to bring with me on Wednesday. In the resource directory, we did everything already. We looked at the layout already. We looked at the values. We didn't look at these directories here. In the old days, we only had one. These are holding our icons. So drawable is from the old drawable. It comes back from swing again. The old drawable concept. There's so much of Java in here. It's images. Multimedia is different. This is pictures, icons, anything that's drawable on the screen. So the drawable has the default, and if you double click on it, everything is in a PNG. It also supports JPEG and GIF. So you have your choices. PNG actually runs a little bit better, I think, in terms of a file format because it's sometimes smaller, a little bit more efficient. Yeah, smaller. Yeah, more effective. The icons keep changing as well. So if you drag and drop and stick something in here, you can actually go from like your file system, drag and drop stuff in here. So how you get something in here. Or you can go to the workspace directory and load it into the directory manually. A lot easier to manipulate the files through Eclipse than it is to go out to the workspace directory. And this is the same file structure. So you can pull the APK file out of here. You can put image files into here with ever having to go to a DOS prompt or with ever having to go to the Explorer or whatever. These are all the same, depends on the resolution of the screen that you're working with. Most people only use the first one, and that's the highest resolution. If you want to support some of the lower stuff, you can change the images, scale it down a little bit, makes it run faster, more optimal on smaller screens and smaller devices that support the same kind of resolution. We can create new layouts, we can create new strings, we can create new everything by just right mouse clicking and then going into new. And then we can select from the options down here on the bottom. And for the XML, it's going to be an Android XML file. For packages, we can create a new package, a new class, and this is how you add stuff into the folders. Or you can drag and drop and put stuff into the folders that way as well. So it's your choice. So let's go back. This is a short version of the tour. I highly recommend, actually, if you're brand new, I highly recommend actually reading through these directories here. It gives you a little bit more information on values and generation and stuff like that. Assets, stuff like that. Manifest, project properties. If it says don't edit, don't edit. So we can open up things in a text editor if we want. We can take a look at the files themselves by right mouse clicking and then going to a text editor. We can actually open it up into the editor view as well. So this is all sort of our, kind of the run through on Hello World. And step number 3, you're going to run it with the emulator. Depending upon the type of emulator, it's going to bring up a little screen. I'm not going to run it right now. It'll bring up a little screen. It's going to say Hello World on it automatically for us. If it doesn't show up, it means there's probably something wrong with your configuration. And it probably means you also have to configure an emulator. And before you configure the emulator, or use the emulator, you have to go into the AVD manager and actually have to build an emulator that matches the same API level that you built for your phone. Even though you might want to test on a 4.0 and you built a level 10 API 2.33, you have to actually have a 2.33 emulator, which is kind of weird. The emulator actually has to match the API level you've selected. Although you don't have to, you can take the file and run it on anything you want, which is weird. So as long as it's backward compatible. So the drill will have you run through and create an emulator. I highly recommend doing that as well. And then we have essentially built our first application, which so I was going to tell you this is way too easy for you guys. There's nothing to this one. So the simple activity class, there's 4 main types of component classes, and this is a little bit more I gave you already in the lecture. I highly recommend reading through this. It's the same information, it's just done in a slightly different format. This is the activities, the services, the broadcast receivers, the content providers. It's interesting to note because the first project we created was an activity, and the default project will always be an activity. And going into a project clean and then build project as well as another option you can get. So getting the user's name, what you can do, in fact, I'm going to leave this to you, actually. Yeah, you have to do something, right? And actually, the more you do now, the better. Because project number 2, I might do some, I'm not going to do the GUI stuff for you. You can do the GUI stuff. But I'll lead you in the right direction, however. So in getting the user's name, and creating the user interface. You're going to take the same main.xml file. Did we have a problem? Oh, okay. Oh, shoot, was the one that had the music? No. Oh, the attendance list, okay. So to get the user's name, we're going to have some sort of an input box, and we're going to create a user interface that does this. And believe it or not, you actually have the instructions here written here. So you can select File, New, Android, XML, and you can actually, in fact, this is not a bad drill to actually do. If we created a new XML file, all we have to do is change the manifest to load the new XML file. And I'll do a little part of this so you can actually kind of see how it works. And the screen is going to be called namegetter.xml, which is on the bottom here. Let me zoom in a little bit if you're reading through the instructions. So we're going to create a new Android XML file. And we're going to do that, and we're going to put it in the layout directory, and we're going to call it namegetter. So I'm actually just going to cut and paste this here because I don't like typing. So I'm going to copy it. And I'm going to go over here to the layout directory. I'm going to right mouse click, and I'm going to say new, and I'm going to say, oops, Android XML file. And I'm going to use a linear layout for this file. And this is where I was going to say I'm going to cut and paste. I'm going to right mouse click and paste it in here. So I'm going to call it namegetter.xml. So I'm sort of doing this for you, so it's all right. Because it's interesting to see it work. So finish. And so now you see namegetter is in the layout directory. If I stick this and I can create a menu, actually I can create another one called menu. And that's a common place to put menu items. Menu items we're going to see in the next project for options menus, for different types of interfaces. Are all done in XML, but it could be put in the layout directory, but it's easier to put them in a menu directory to keep them separated, organized, so we know what it is. And then we we open up the menu. So we created this new namegetter XML file, and I double-clicked on it to see that it would open up in this window over here, and I see it. I'm going to close this one just for clarity. I'm going to change it. So here's our namegetter. Our namegetter has our title bar on the top of it. And what is namegetter going to do? It's going to get a name for us. So we're going to open up the new file. We're going to select the tab labeled namegetter.xml. We're going to switch to that one. This should be located in the bottom left-hand corner. We did all that stuff already. What are we going to do? We're going to be able to see XML opening, yada yada yada. Make a few modifications to the linear layout by editing the attributes contained in the opening layout tag. We're going to set the layout labeled Andrew layout underscore width, height. Well, you can do that yourself. Tells the Android that the linear layout should take up the available width and height of the screen. So leave the attributes alone that are set to vertical. So essentially you can say, the layout is going to take up the whole screen. It's going to take up part of the screen. You can actually, in the older versions, you could have dragged and dropped the layout. This one's not visible. If you look at the layout, and let me just show it to you, because where it's I'm looking at, you don't see it. It's all black. But if you click on here, you can see it here. It's going to match it already. So it's actually already set by default to what it is we wanted it set to. So we can't stretch it because it's not visible. It's just taking up the entire screen. So let's see. So now we're going to add 3 elements to the UI, and the 3 elements we're going to switch back to the graphical view, and we're going to drag and drop those elements. So this is going to be form widgets. And I won't do the assignment for you, but I'll just put some stuff on there so you can kind of sort of see it work. Maybe I'll put part of it on there. So we're going to open up the category called form widgets, which is going to give us our form items. We're going to drag and drop a text view onto the black canvas. And we're going to put a button on there too. So what do we got? A text view. Layout editor will populate. Get to steps for. I'll put a text view and a button on there. Okay, so we're already by default in the form widget. So we could put like a large text here. If I double clicked on the text, I could put something like type your name. It's just a prompt to the user. And if I switch back, I can see it sort of changed to type your name. And then I can put a input. No, I should just put the text field here. Text fields here. I can put one here. Plain text. So we have different types of text fields. Basically, you learn them by experimenting around with them. in your text fields, your form widgets are going to be your labels, your buttons, and I would highly recommend if you're one of those that needs to learn by example, get one of those reference books. You know, like kind of it'll tell you what everything is. It's kind of like an encyclopedia or a dictionary. Look at all that. Or you can do what I do and just learn by poking around. So you can drag different things over. I'm going to put a box. I'm going to actually put a big button here. And I'm going to just say go on here. Go. And this is the name getter screen, which is different than the main screen. Here's going to be, you're going to put your name in there. I'm going to press go or something. Let's see. Edit your name. Okay. Oh, I didn't put the hint on there, but go ahead and read through this and put the hint on there. Where, if you put your mouse over the input field, it'll say enter your name. A little hint that pops up, shows you that stuff. Put a button here. This button's going to just say OK on it. All right. So now we're going to create a new activity class. So we have a new, and this is kind of showing you the way the format sort of works. So we have our main class that we created for us automatically, and we had it linked to main. It's not a bad idea just to create more classes, more activity classes, and link them to more GUI screens, because then we can switch back and forth between the activities, and we have one screen that kind of manages each one of the activities. You don't have to do it that way, though. You can have one screen work with all of the different classes, and you can have one class work with many different screens. But this particular exercise is trying to get you to create stuff. So we're going to create another class in here. So when we create a new class, we're going to call this one a getName as our class. So if I come up here and I click on the source directory here, and I mouse click and I say new class, and I'm going to call this class getName. So this particular first activity had me create a new user interface, new UI, and also a new name. And in here I see it says getName in my new little class here, and it's under my same project, and I see getName up here. Interesting thing is I don't see activity, which is kind of interesting. So we got main's right here actually with onCreate in my activity, but my getName doesn't have anything in there by default. So you're not going to see that until you create your first project and you create the first activity. Then you see that onCreate. When you create new classes, you don't see that by default because I might not necessarily want to do an activity. In this particular case, I don't. So it should be in the source folder. I see getName. This is exactly what I see. Modify it to extend activity and implement Android view onClick listener. And finished code should look like this here. So what I'm going to do is I'm going to cut and paste actually. But I'm going to cut and paste from the imports instead of the package because I don't want to mess it up. And you can do this actually, and it should work just fine for your particular program as well. So I left my package information on the top because it was different than the example. I'm going to paste it. And now you see I've kind of created, oops, get rid of this here. That was my original class. I probably have an extra, yes I do, I have an extra closing bracket. So what I've done is I've sort of made this like the original, oops, get rid of that, the original activity that was created by default by extending, so I'm extending activity, and now I'm implementing an onClick listener because each one of the button activities, each button I put on there, I can attach an onClick listener to it, so when I click the button, some activity is going to be performed. And it's an implementation because it's from a pre-built functionality. I'm going to talk about listeners next week, actually, or next Wednesday. But for tonight, let's just keep it as, a listener. We're attaching a listener, we're implementing a listener, which is an interface. So we extend, we're not going to get this till we see the Java, and object-oriented programming in Java class, but we extend for inheritance from activity. We implement interfaces using implements. And so we're actually implementing a method for onClick listener, which is going to be for our button activity. And our button activity has one method called onClick. So because on the click, it's going to take the name and it's going to use it for something. So the finished code should look like this. Obviously, I just cut and paste it. You can cut and paste it as well. Now declare a data member of type Android widget edit like this. and then it's gonna hold a reference. So what this is this is nothing more than a variable, and it's a variable for a reference for the name that's going to be used when the person types their name into that input field, that text field. If this is too fast for you, don't worry. You can download the assignment, and you can actually do this a lot easier on your own, a lot slower. So in the get name, I'm going to add this variable here. And it's just nothing more than a variable with a data type. The data type is an edit text. If I could take this out actually. If I took this out, it'd give me a little message that says, what do you want me to do? Import it. So I can import edit text. Now I have added it up here, which is the same sort of thing that we're doing with all of the other packages. And if you were in the Java programming course, we saw packages, we saw imports today. This is essentially what it's doing. Is from this particular package class, we're importing the edit text functionality. And so we have this edit text name that we can use as a variable. Because what we're going to do on this click method is we're going to take the name that's in the box and put it in here, and then use the name to say hello something or other. And the user clicks on hello world. So then we're going to add the method with the following signature public onCreate. So we're going to put that onCreate method in there. And the onCreate method is going to have, and I'm just going to scroll down to the bottom because I'm just going to cut and paste the whole thing in there. The onCreate method, in fact I can let you do this as well, it's pretty easy. It's going to start and it's going to initialize when the class is being started. We could have essentially added this to the original activity that we had if we wanted to without creating a new one, but you wouldn't have the experience of doing this. So you're going to cut and paste, you're going to put in the onCreate, and you're going to if you go down to the bottom here, you see the full code actually. And then this is going to give you the activity that occurs that's going to create the functionality for when the class is actually instantiated. So it makes a call to, and then you have to change it to the button ID that you used in the button interface. When you do that, it will actually call the button and take the information that's being handed back and forth. This is the completed, I believe, at the bottom here. I'm going to get to the bottom. Too much to read through. The missing link to this, I'm going to do on Wednesday. I'm going to stop because I'm feeling rushed right now. So let's stop for tonight because we already hit our time. Read through between now and Wednesday if you want to keep on track of this. Read through all that stuff I skipped through kind of quickly. And what we're going to do is finish the name getter, because there's a lot more to this than I originally remembered. And then we're going to edit the manifest to work with the name getter. And we'll see how the XML files work with the classes and how the onCreate works. And I'll probably spend most of the class time finishing up this assignment. So we'll be done with this assignment on Wednesday. So I'd rather do that. I feel like I'm rushing right now, so I'd rather do that a little slower. So see as far as you can get through, then if you stop halfway in the middle and you have problems with it, you'll probably get your questions answered. And feel free to cut and paste. The code itself should be reliable. I mean, I wouldn't type the whole thing. I just cut and paste and put it in. It should work for you. Questions, comments, or concerns? So we have class on Wednesday. Monday is a holiday, so we get a first Memorial Day holiday next week. So don't come to school next week on Monday. Sign the roster if you haven't done that already. And we're going to pick up, read assignment number 1. It's on the bhacker.com website. The EMS has not been populated yet completely, but eventually the assignments will be there as well. And this is assignment number 1, so it's worth your advantage to actually start implementing it. And then we will finish this. I'll dedicate most of the probably 100% of the class time to explaining the rest of this assignment at a lot slower pace. So, okay, we're done. See you next time.